Hello students, welcome to Shoras's classes. Today we will be solving some IIT JAM Chemistry questions from this year, that is 2018. So we have question number 11 in hand. With respect to the periodic properties, the correct statement is, and we have 4 options given to us. We have to choose from among these 4. So option number A states that the electron affinity order is fluorine greater than that of oxygen greater than that of chlorine. Whereas option number B states that the first ionization energy order is aluminum greater than that of magnesium, which is greater than that of potassium. So option number C states that atomic radius is N greater than P greater than AS, and option D states that the ionic radius order is K plus greater than CF2 plus and which is greater than Mg2 plus. So we have to choose from these 4 options. So starting with option number A, we have electron affinity order. We know that under group 17 we have fluorine and then we have chlorine, and the electronegativity decreases down the group. So fluorine is greater than that of chlorine. This is the electronegativity order, but we have to remember that F is a smaller atom, whereas chlorine being situated below fluorine, so it has the added advantage of getting another subshell to it, so it has a larger size which is greater than that of fluorine. So size wise we have chlorine greater than that of fluorine, whereas electronegativity order will be F greater than Cl. But since the size is smaller, so the tendency of fluorine to become F minus will be lesser than that of chlorine to become Cl minus, because when F becomes F minus, then the inner electrons of fluorine will repel the newly acquired electron in F minus. As a result of which F minus will be much less stable. That is, the stability of Cl minus will be much greater than that of F minus, owing to the greater size of Cl or owing to the lesser size of F, whichever way you can say. So we have electron affinity, which is the tendency of an atom to become the negatively charged atom. The tendency of an atom to gain an electron is the electron affinity. So the electron affinity order of F minus will be lesser than that of Cl minus. So we will have electron affinity wise, electron affinity or EA will be that of fluorine will be greater than that of oxygen but lesser than that of chlorine. So this will be the electron affinity order. And going back to the question, we can see that the electron affinity order is given F greater than O greater than Cl, which is not true. So we can successfully eliminate option number A. The correct order will be chlorine greater than fluorine greater than oxygen. So moving on to option number B, we have the first ionization energy order is aluminum greater than magnesium greater than potassium. So what is first ionization energy? Before that we will say what is ionization energy. It is the energy given to an atom to take out an electron from it. So basically it is the energy we give to an atom in order to make it positively charged. And first ionization energy is the energy given to an atom in order to take out its first electron or its valence electron or its valential electron. So this is represented as IE1 or I1, and this is represented as IE or simply I. So we have to find, as per option number B, the first ionization or energy order of aluminium, magnesium and calcium and potassium. So referring to the electronic configuration of magnesium, we have Mg as 1s2, 2s2, 2p6, 3s2. That of aluminium is 1s2, 2s2, 2p6, 3s2, 3p1, and that of potassium will be argon 4s1. So since we have to find the first ionization energy order, so basically what we need to first get is the K plus, Al plus and Mg plus order, because after taking out the first electron or after giving the first ionization energy, we will get K will be now K plus, Al will be now Al plus and Mg will be now Mg plus, because we have given it the first ionization energy, that is we have taken out one electron from it. So the order for K plus will be argon 4s0. This is the electronic configuration of K plus. That of Al will be 1s2, 2s2, 2p6, 3s2, 3p0, and that of magnesium will be 1s2, 2s2, 2p6, 3s1. So we can see that here K plus has a 4s0 configuration, so basically it has gained an inert gas configuration owing to the first ionization energy, because it has 4s0 which is an empty shell, and hence its configuration is same as that of argon which is an inert gas. So it has attained inert gas configuration, which is the dream of any element. So the ionization energy of K plus, that is ionization energy to transform K to K plus, will be the least, because it has become stable due to the first ionization energy. For aluminium, it has no electrons in its p shell, so 3p is 0. As a result, aluminium will have a tendency to lose an electron in order to make its 3p orbital empty. But magnesium has a half-filled s orbital, and previously it had a full-filled configuration. So the tendency of magnesium to become Mg plus will be the least, hence the ionization energy required to make magnesium into magnesium plus or Mg plus will be the most. So the ionization energy of Mg to Mg plus will be the highest, and ionization energy of aluminium will be sandwiched between the two. So basically we can say that, moving on to the next page, ionization energy order will be something like this. Aluminium will be sandwiched in the middle, and we have potassium as the, this is the stability order for K plus, Al plus and Mg plus. So ionization energy order will be the reverse of this. So Al, Mg, reversed will be this. So basically we have magnesium greater than aluminium greater than potassium for ionization energy order. So moving on to the next option, we have the atomic radius of N greater than P greater than AS. Now, referring to the periodic table, under group 15, that is nitrogens, we have nitrogen, then phosphorus, then AS. So we know that down the group the size increases, so the atomic radius order will be AS greater than that of P greater than N. This will be the atomic radius order since down the group size increases. So option number C is also incorrect, and we have also already found out that option number B is incorrect. So what we have left is ionic radius order of K plus is greater than that of Ca2 plus, which is greater than that of Mg2 plus, and this obviously has to be correct because this is the last option left to us. Still we will check this out. Referring to the periodic table, we have under group 2 we have first beryllium, then Mg, and then we have calcium, and here we have potassium, then above it we have Na, and above it we have Li, and here there's hydrogen. This is group 1 or alkali metals. So basically we are interested with these three, and we have to find K plus, Ca2 plus, Mg2 plus. So we can basically say that for Ca2 plus and Mg2 plus, because size increases down the group, so Mg2 plus size will be lesser than that of Ca2 plus. Also, now potassium plus and Ca2 plus this has plus 1 charge, this has plus 2 charge, and we know that as charge increases the size decreases, and since they belong to the same period, so the size of K plus will be greater than that of Ca2 plus because of this plus 2 and this has plus 1. So overall the size order will be the ionic radius order will be something like K plus greater than Ca2 plus greater than Mg2 plus, and if we refer to the question itself, that is the option number D. So the answer is option D. Thank you.